It's an endless loop.
So let's start with this. This is the functions. On the test, I'm going to give you a list of functions, F, G, H, maybe J. But you get that list of functions. You can write it down for now. We're going to do some operations with the function. We're going to do some operation with functions. So please write this down.
Like this review?
Yeah. And it's recording. Please don't say anything.
Yeah, if you tend to.
Please say nothing that's after recording. Of course, always. So the first thing we're doing is function operations. Yeah, it's a video that's recording. Stop talking, please. So first thing we do, it will look like this: f plus, let's do h of x. F of h plus h of x, something like that. So with that in mind, what that tells me that I'm going to do is f of x plus h of x. Once again, it will do f of x, I'm sorry, I should put the parentheses, plus h of x. So then, with that in mind, you're going to plug that in. 2x minus 1 plus x squared minus 3. Combine like terms. We did this last test or 2 tests ago or whatever. You just combine like terms if possible. X squared plus 2x, negative 1 minus 3, minus 4. You do not need a factor. Don't factor. No need to do that.
I don't understand that.
I just replaced the f and h with the functions that are equal to.
Why is there also an x?
That's how you write the notation. So f of x and h of x. If I put a number in there, we plug in a number.
All one problem.
Those are two different problems.
All one problem.
This would be like the bank of the information you need, and then on the sheet you'll have a bunch of problems based off that bank.
Oh my god, I was like doing F of X plus 8. Wait, can I write this down quickly?
Yeah, get it down. That one is adding, subtracting, same concept.
So what's x though?
X is just the variable that we use to represent the input. Now, since we didn't put a number in there, it stays x. When you put a number in there, you actually plug in a number.
That's
We'll do that.
change every time, right?
The F, G, and H will change every time. But this is how it would look like on the test. So what the actual numbers are is change. Okay. If I say F times, let's do G
She got a 30?
of X.
What?
FOG? FOG?
F times G, not FOG. I'll talk about FOG soon. But F times G. So that means it's going to be F of X times G of X, which means I'm going to rewrite it as 2x minus 1 times, I don't have to put a symbol in between it this time, 3x plus 2.
This you factor?
This, not factor, but FOIL. Or there
Wait,
should
do
be.
you multiply it there? Do you combine like...
You multiply since it's multiplication. This one's plus, so you combine like terms. So this is going to be foiling 6x squared plus 4x minus 3x minus 2, 6x squared plus x minus 2. So combine like terms if possible. In this case, you can. So that's it.
So F of X is that whole thing, the G of X, the H of X, that in the box, that's what you're going to give to us? Like, that's always going to stay the same?
The numbers themselves are going to be different, but they'll be same per each question.
So it's the same as addition except just multiplying.
Yeah, that's true, I guess, yeah. Instead of addition is multiplication.
Wait, so when it's multiplication, you do the factoring out of
Not factoring, but multiplying.
multiply. So like 2x times 3x and then 2x times 2.
Excellent, yes, like that.
Are you recording this now?
Yes. And it's recording, so try not to say what? It's recording also. Alright. Since it's recording, what's going on? using the same F, G, and H. Oh. So using the same F, G, and H, let's do our next problem. So it's going to be F of G of X. Yo, stop talking. So F of G of X. So notice this is an open circle. When it's an open circle, that means it's F of G of X, which we're going to rewrite it like this. F of G of X. That means the G of X is inside the F of X.
Wait, this is zero multiplication, right?
What?
This zero,
Is not multiplication. It means F of G. F is, or G you could say, is inside the F of X. Which means I'm going to substitute this G of X with what G of X actually is.
3x plus 2?
3x plus 2. So it's going to be F of, red, 3x plus 2 So then, when you do that, every x in the f of x becomes 3x plus 2. So it's 2 times 3x plus 2, because this x just became 3x plus 2, minus 1, because that's the 2 in front of that x.
You take that.
So what you don't think of it as I'm taking it. I'm taking this and plugging it into the x. Okay, I'm taking it and plugging it in. Because a lot of people see the 2x and they forget the minus 1.
So you just
This is going to be, somebody will get this wrong. Don't forget the minus 1 at the end.
So we just forget about the x and just put the rest of it?
That's the answer.
The x becomes the rest of it, yes.
Is that the answer?
Then you do a little bit of math to simplify it.
Oh, this makes sense.
6x plus 4 minus 1
6x minus 3.
plus 3,
Oh.
and then you're done.
Same thing.
That's his own question. I'll sector that off. F of H of 3. F of H of 3. So I'm going to rewrite this.
But this is a different.
This is a different problem. F of H of 3. So the difference here is now I have an actual number. Because I have an actual number, I can figure out what H of 3 is. H of 3 is every x becomes a 3. So this is going to be rewritten as 3 squared minus 3. I'm looking at the H equation. So 9 minus 3 gives me 6.
Wait, can you repeat that?
Yes. If it's H of 3, because this is the letter H, I'm using the H equation over here. And because it's a 3, every x inside it becomes a 3. There's only one x in that case, but every x becomes a 3.
We're doing the 3 squared.
Well, it's x squared, so it has to become 3 squared. This 3 was an x before it. So then 3 squared is 9. 9 minus 3 is 6. So H of 3 equals 6. Since they're the same, I can substitute them. And I'm going to rewrite this part as f of what number?
6.
6 is going to be f of 6. Because I figured out H of 3 equals 6.
What do you mean they're the same?
H of 3 equals 6, because when I plug in 3, 3 squared minus 3, 9 minus 3 is 6.
Did you then plug in the 6 for that equation?
Into the F equation. Good. Now I'm going to take the 6 and plug it into the F equation. Before I had to plug in a whole equation. Now I just plug in a number.
With 11.
So 2 times 6 minus 1 equals 11. So your final answer here is 11.
I don't get how you take the 3 and put it.
What don't you get?
How is that different from the other one you did?
So the other one, the problem was I had x's, right? So I can't plug in a number here to find a number. So I just have to plug in the whole equation.
So instead equal. Right.
But here, since I have the number, let me find the number so I could just change it to 6. You could put 3 squared minus 3 into here, but then simplify it to 6. Okay?
When's our test? Wait, can we go back for a second?
Tuesday?
You didn't touch it though.
I don't care if you touch it.
What?
You didn't know when.
I'm moving on. Okay. There's different variations of that type of question. Look at your homeworks. They'll show you all the variations possible.
You finished?
That was 3.3.
That's 3.3. Inverses, which I believe was a 3.4.
I was gonna do that.
Oh no, I think graphic is 3.4. No, that's
Where I
3.5.
can go over.
So 3.4. Inverse. Okay. When I ask you to find the inverse of a function, I'm going to give you some equation. Like f of x equals, stop talking, 7x minus 2 over 5. I'll give you something like that. And I want to ask you, please find the inverse, or f of negative 1. So if I want to find the inverse of this, my first step is to make it a y. So y equals 7x minus 2 over 5. So the first thing I did is make it equal y. Then, every x and every y swap places. So the x will go to the left, and then the y will go to the right. So 7y minus 2 equals 5. So all I did is literally rewrote my x's as y's and my y's as x's. Now my goal is to get y completely by itself. It's part of the question. So then I'm going to multiply 5 on both sides. So I have 5x equals 7y minus 2. From there, I'm going to plus 2 on both sides. 5x plus 2 equals 7y. Then I'm going to divide it by a 7. 5x plus 2 over 7
If you're multiplying it by
equals
both
y.
sides, that makes 2 become 10.
Say that one more time.
If you're multiplying, no, if you multiply it by both sides, then 2 becomes 10.
No, because this 5 here gets completely canceled out by the 5 here.
Oh, fine.
So this cancels out and doesn't touch anything on the top. The reason I multiplied it by 5 to get rid of that 5, so it perfectly works out like that. So your answer is 5x plus 2 equals 7. That's your inverse. Yeah.
Oh wait, never mind. I'm going to take added.
But don't you write it as like, I don't, do you want us to write it as like f negative 1?
This is good. Technically, the final form will be f of negative 1 of x.
Do you care?
No, I won't take it. I will not take off points if we do it like that.
Let's say if we do like F they all have, they're all divisible by a certain number. You have to like,
I will not take points off if you don't simplify, because that's what you're asking.
but like also I'm asking if that was true, like let's say it was like, I don't know, like 10, 5, like
If it was 10 plus 2 over 2, you could reduce it all down, yes.
so, but it would be the same.
It'd be, I'll give you full credit as long as you get to here. Until the y by itself. Wait, I'll, and then,
I'm not talking about so the final answer is basically the 7 and 5 switch places and all different signs.
yes.
Is that like
That's what an inverse is.
that's
They're
basically-
inverted. It's
So
the
it's
opposite. It's
not
bizarre.
a coincidence like this. So theoretically, if I were just to do guess work, I could just do the inverse and get.
You could also guess wrong. That's the problem with guess work.
Not here.
No way.
Oh, I know.
You gonna take a phone call, man? Put it down.
Wait, what is the thing next to the fraction? Like, what's the thing that's crossed out? What does that say?
It was a times 5. So times 5, they cross out each other. Let's do another inverse. I'm moving on. Really?
Like,
F of -1 is the official form. If you don't write it, you're not gonna lose points on it.
And what?
You will not. F of -1, so x to the -1 power. F of x equals 10 x to the 4th plus 3. Okay. Let's stop talking. Let's stop talking. So for this one, let me try my best to invert it. But there's going to be something weird that happens with this.
this is part inverse, right?
This is still inverse, but there's something weird that happens here. So let me swap. Then let me subtract. Then let me divide. Then let me fourth root. Since I'm fourth rooting on both sides, what does that cause? A what?
Plus minus.
Plus minus. So plus minus the fourth root of x minus 3 over 10 equals 1.
How do you fourth root on a calculator? You just change the 3 to 4.
You don't have to actually do the math of a fourth root. If you need to do fourth root in the calculator, you could do the number to the power of 1 over 4.
Are you gonna make us do that?
I don't think anything explicit.
So I have to go outside of the
That was on the quiz, so no. I'm probably
So I have to go outside of the root.
It's going to be by itself, so also outside.
Like I'd say I like make it like the line too long against each other.
I mean, how? It's the equal sign. It's not all square fourth rooted. It wouldn't make sense. All right, pay attention here. You're going to lose points if you don't know what to do. In this one, there's an issue. A function by rule says that when I plug in something, I only get one thing out. Okay? Every input has only one output. That should sound familiar. The problem with this is because there's a plus minus, that means what I plug in gets me two answers. And that's an issue. I cannot have that. So, this is no inverse.
I thought-
I will still give you full credit, but it's no inverse.
Is it always when there's an exponent still inverse?
So what kind of exponent would cause a no inverse?
Plus minus.
Even.
And what kind of those are those? Those are even.
So do we have to show the worker if we see if it's?
If you see it's even, you say, yeah, no solution. Save yourself some time. Okay? Yes, go.
I thought there would be like, let's say one solution would work, one wouldn't. Like a straight answer.
I would have to, what we say, restrict the domain, which I didn't do that, so. If you remember in the homework, there was like that x is greater than or equal to 0. You remember seeing those questions?
Yeah, those were right.
But I told you to ignore those.
Oh.
So that part is necessary in order to make it invertible. But I'm trying to teach you the fact that not everything's invertible, so I want that part avoided.
Oh. But technically I can have a straight answer.
If I restrain it, or I say only like a half of it, then it'll be fine.
Okay.
Okay? All right, the next part of the test will be, technically will be 3.6, and I'll bounce back to
Not
3.5.
3.5.
The last part, I'm going in order of the test.
What if it's odd? If it's odd, it's fine.
It wouldn't matter, yeah. Odd is okay. So 3.6, this one will be, I think it was like root equations or something like that. Yeah, radicals are roots. So. Well, let's do something simple. X of 3/4 equals
Wait, we're not doing.
3.5 on the test is the last thing, so I'll just do it last. Okay, shh, no. So, x of 3/4 equals 8. So, to get rid of the exponent, I'm going to use the reciprocal. Remember though, it is not 4/3 times 8. It's going to be, I'm doing a different color, 4 over 3, the power of 4 over 3. So x equals, you could rewrite 8 4 over 3 as the cube root of 8 over 4. By the way, you have a calculator the whole time. So if you have this, you can type in your calculator 8 to the power of 4 divided by 3.
Do we have to? If we just did this, we don't.
No, find the number. So then the cube root of 8 is 2. 2 to the 4th is 16.
That's it.
That's it.
Wait, how is this? Oh.
Oh wait, so if you were to plug in 16 to the 3 over 4 power, that would be 8.
8 to the 4/3 power
No,
is
I'm
8 is 16.
So I'm saying
16 to the 3/4 power is 8. Another example.
Honesty is the best policy.
She's gonna be here.
All right, this one divided by 2 on both sides. You want to get the square root or cube root or whatever exponent I have by itself before I deal with it. So I'm going to rewrite this as the square root of x minus 4 equals 3.5. Oh, shoot, that sucks. Make this an 8. So this is a 4. I don't want a fraction. Make this an 8 like that.
So
Are we gonna have
fraction on
fractions
the
on the
test.
test?
Probably not.
Oh.
Wait, wasn't that just an 8? A
Yeah.
7?
Yes, make it an 8 so it's clean. So then I'll square both sides. So x minus 4 equals, do I need a plus or minus here?
No.
No, so it's just 16.
Wait, how do you know when you need a
Or not just
When you
basic.
square root or even root, I should
Not
say.
basic.
Why do you square it?
Plus 4, because I want to get rid of the square root.
Wait, so why would we need a plus minus?
When you do a square root, because square roots could be, if the square root of 9 could be positive 3 or negative 3.
So listen, why would this do that?
It's not a square root, it's a square.
Oh, fine. What's the call?
So x equals 20. Square root of x plus 2 plus 4 equals 3.
Is the 4 in the?
Say it one more time.
No, it's K.
Is the k value of we're graphing?
Is it a K?
X plus 2 equals negative 1. Now, in this one, am I allowed to square it even though it equals a square root? Why not? Why would I or would I not?
There's a 4 on the answer.
There's a k or 4 on the outside. No. But the problem is, when I get the square root by itself, it equals negative 1. Can my square root equal a negative?
You have the absolute value, right?
You don't have to. A square root could be a negative, because remember, when we square root something, we get the plus,
Plus or minus.
minus. So it's okay to have a negative here.
With no inverse.
So square, x plus 2 equals positive 1 in that case.
Wait, so when is it not plus minus?
Say it one more time.
When is it plus minus then?
When you square root both sides.
But you just, oh, I get it. You did not.
Minus 2, x equals negative 1. Right. Look at your homework for more examples. But this is the general.
Wait, where's the graphing thing where I go look at the
That's the next thing we're going to do.
Are we done for the test? No.
We're going to do the graphing thing.
Is that the thing that was yesterday?
Yes.
No. That was like
No.
4 days ago. That was like 3 days ago.
Centroid? That was an accident post. Don't
Oh,
worry
I
about
don't know.
Wait, it's 3.7 on the test.
that. No, it's going to be 3.5 next, which is the graphic.
So no 3.7. We didn't have a 3.7.
Yes, that's why it's not on the test.
Why did he ask that?
Because you told me like yesterday it was going to be 3.7.
My fault then if I said that. All right. 3.5, which is the graphing. In the graphing, it's going to give please graph the function, so it's graphing, and give the domain and range. So, f of x equals 2, oh no, it's also going to tell you to talk about the transformation. So, guys in the back too. You too. So, for this one, first thing I'm going to ask you on the question is to please describe the transformations. To help describe the transformations, I'm going to identify my A, my H, and my K. If these letters look completely foreign to you, you have big problems. You have ever studied. It is A square root of x minus h plus k. That's the generic version of it. So my A value in this case is 2. My H value in this case is going to be positive 3. Very important. You're going to flip the sign, because if it's negative H here, I must have put in a positive 3 in order to be staying negative 3, like minus 3.
Do you always flip it?
Yes, always flip the H. While the K always stays the same. Don't flip that. People get too confused or too eager to flip things.
And you don't flip A either, right?
You don't flip A. So what does each piece tell me? A tells me is going to be stretched by a factor of 2. So stretched by 2. And that's what I mean by stretch is that it gets taller.
Wait,
Can
is it
I
always
BS
stretched by
like
two?
vertical stretch?
No, because the other one's vertical shrink, so I don't know which one you
Wait,
pick.
so
We
it's
used
like
to write it on the board anyway. Last
if
year.
A
Okay,
was
don't do
like
that.
5, would it stretch by 5 or like would it always be 2?
It's by the number it is, so 5. It would be 5.
So why did you write stretch by 2?
It is stretched by 2.
She just said it was 5.
No,
And she proposed a different one. H, since it's positive 3, that means I'm going right 3. And in K, because it's plus 5, I'm going up 5.
If it was negative, 5 would be down.
Yes.
Fine.
These
Fine. If I write BST, is that fine? Vertical
How
stretch.
did you choose that one?
Shrink. As long as I can tell the difference between stretch and shrink. So whatever you think is enough to tell the difference. So, usually, it looks like this. Usually, it looks like this. Let me use a different color, actually, to indicate.
Yeah, what is it?
So, usually, it looks like this. So, in this case, this triangle over here, or this arc over here, my bad, not triangle. It's going right 3. So, you're going to go right 3 and up 5. Of course, you can't actually drag it on the piece of paper. So what I really care about when I look at this,
How do you do the stretch by 2?
you don't have to graph that. Like, it would just be taller. It would just be
On
taller.
the calculator, does it tell you?
It won't tell you what exact point it is, but it will give you a picture that kind of looks like that.
So do you always
So
start
if I just draw it.
So start at 0, 0. This is how you actually draw it. Hey, stop talking in the back. So you start at 0, 0. Since I'm going right 3, I literally move my dot 3. And since I'm going up 5, I will move my dot up 5. I would start my point at 3, 5 and graph. Okay? I would start at 3, 5 and graph.
Then how do you do the stretch by 2 then?
You do not need to graph the stretch by 2, but in general, stretch by 2 just means it's taller.
So if I just put a dot on the
It's
3
twice
by
as
5,
tall, you
so
wanna
put
think
a
of it.
dot by the 3 by 5, is that fine?
And make the arc. You have to
Does
draw
that have to be
the...
perfect? Like,
No. So then, in that mind, the last part of this question is the domain and range. Normally, the domain is at 0, but I just moved it 3 to the right. So what's my domain going to be?
3.
X is greater than or equal to 3. That's for cube roots. And we'll do that next. My range is usually at 0, but I just moved it up 5.
X is greater than 5.
So Y is greater than or equal to 5.
And if they're negative,
Because that's what the point.
If it was negative, it will go down. So it'd be Y is less than. No. The only time it will be less than. If A was negative, that would flip it upside down. So then it's Y is less than that.
Because I think it'll be those numbers, right? Because it's like that's where the point starts. I think
Yes.
below it would be the domain.
Yes. Yes.
So it's like where the arc is intersected.
Where the arc starts would be the best word.
I'm saying like, but all the values greater than.
Oh,
the-
yeah.
the arc.
Fair enough. Okay. Let's do a cube root one.
Wait,
I'm sorry.
And if there's no number like by one of them, you assume it's 0, or if it's A, it's 1, right?
Yeah. F of x equals 2/3, negative 2/3, the cube root of x plus 4 plus 1. Negative 2/3, the cube root of x plus 4, then minus 1. Or plus 1 plus 1. So identifier A, B, and C, or A, I'm sorry, not A, B, C. This is a different one.
2/3.
So we're going to identifier A, H, and K. It is the same format. The only thing is it has a little 3 in the cube, or in the root.
Would it be negative 2/3 is the A?
So A is negative 2/3. H is going to be negative 4 because you flip the sign. And then K is positive 1. That sign stays the same. All right. Each one tells me, A tells me 2 things this time. First, it's going to shrink. So I'm going to say squeeze also. But shrink by 2/3. The reason it's a shrink,
Because it's a negative.
no.
What?
It's shrink because
Less than
it's
one.
less than 1.
Do you
2/3 is smaller than 1. If I give you 4/3, that would be a stretch by 4/3. Aaron first.
Do you mean that like transformation, like what you're writing right now, but like shrink and all that?
That's what it means by transformation. Yeah. These are the things that are transforming compared to our original basic line.
Why would you put negative?
Or you get like a point.
It is not shrinking by negative 2/3. It's 2/3 the height. What the negative does something else.
Flips.
It flips it.
Would we get like a point for like writing like H, A, and K correctly, and then a different point for like drafting it?
Yeah, that's why I'm breaking it into more pieces, just so less errors. Or I can give more partial, I should say. All right, H. H is negative 4. Negative 4 is going which way? Left. So it's left 4.
You have to have vertical flip, or you could
If you wrote flip, I'll be fine.
Alright.
But flip or left 4. And then this is 1, so up 1. Please, you have to put the directions here. If you just put like a +1 or like -4, I don't know if you know that means left or right. You have to put you're going left 4.
Let's see on the
Wait,
I will not assume
what do
correctly.
you mean
I will
by
just give you wrong.
What do you mean by vertical flip? Is there a horizontal flip?
There is a horizontal shift, but we do not talk about that at all.
Do I have to write vertical flip?
If you write flip, I'll take that because there's only one flip we ever talk about. But left and right is whether you go left or right for that. All right. So normally our equation would look like this. But there's a couple of things happening in it. One, it's moved left 4. It moved up 1. Also, it vertically flipped. Can I flip it for me? Oh, yeah. Okay.
Wait, what's different about the other one? Like, why is that a squiggly line? The other one didn't.
They're different
I'm so
equations.
So when
So
it's cubed, it'll have a squiggly line.
it's a full squiggly, yeah.
But when it's not, it's regular.
Just an arc and a square. So you would graph it like that. The key part that I take away, like what I'm looking at, is not only the orientation. So it looks like this. So it's upside down. And the other part I'm looking at is at this point. This point should be, I went left 4 and up 1 from 0. So -4, 1. That should be the point that I see.
How do you know when there's like 2 squiggly lines and not just 1?
So if it's a square root, it's just the arc. If it's a cube root, it's the full squiggle.
What if it's a fourth root?
It'll be back to the arc, but we don't need
Yeah?
Oh, no, not that.
Okay. So even ones are just arcs. Odd ones are squiggles. The only difference is they're like a little bit sharper the higher the power.
Is that it?
Well, then domain and range.
Elizabeth?
But lucky for you, the domain for the domain for cube root is always all reals, no matter what flip, switch, stretch, shrink you do.
Wait, why is it all real?
Why do you think it's all reals? It's because all the numbers could be cube rooted, so it's okay. Yes.
So is it always gonna be that your
H always represents your x values.
and K always represents your Y?
Yes. So if you remember vertex form from parabolas, it's that same thing. They actually work for any type of expression or any type of function.
So A is just your slope.
Slope is not the right word, but it is your rate, like you're changing.
So how much is to know if they could all be like cube rooted? If it's just an automatic.
You need to know negative numbers could be cube rooted. That's just a fact.
Yeah, because like,
But
I don't
square
actually-
root-
I don't actually do math. I just have to like know that, and that's it.
Well, if you know that, then you could figure out that the domain and range is all reals. Or you could just know when you see cube root, all reals.
Let's say it's like -2/4.
Doesn't matter. It's all reals.
So when I just see a cube root, it's all real.
Yes.
Okay. Is that it?
Yeah, that's it. Again, this doesn't actually cover all the types of questions. Or, I'm sorry, let me rephrase that. This covers all the topics, but this doesn't give every example. Use your homeworks. I'm going to give a worksheet, if not print out a worksheet.
On Monday.
Let me do it now, actually.